So just a couple of reminders. This is Radical and Rational Functions Lesson 5. We've been looking at asymptotes, places where the graph gets really, really close to but doesn't cross. We did talk about horizontal asymptotes being a little strange in that they are values that the graph approaches as x gets very, very large or very, very small. So as x approaches positive or negative infinity. We're looking today at some different considerations, specifically when we're studying rational functions that have no common factors. For example, the polynomial might be described as x plus a, x plus b over x plus c. There are no common factors, but what we can say is that x cannot be equal to negative c. That will create a problem with the graph. Specifically, because x cannot equal c, that will create a vertical asymptote at x equals c. Now we've got some playing around to do with horizontal asymptotes. We talked about how to deal with horizontal asymptotes. We'll get some more experience with this exercise. But if the degree of the numerator is less than the degree of the denominator, for example, y equals x over x squared, then the line y equals 0 is a horizontal asymptote. If the degree of if the degree of the numerator is equal to the degree of the denominator, for example, x cubed over x cubed with coefficients like a and b, then we saw that the line y equals a over b is a horizontal asymptote. And if the degree of the numerator is greater than the degree of the denominator, for example, y equals ax to the 4 over bx3, then there is no horizontal asymptote. The graph will continue on and on forever. And then the nice calculus sounding word, points of discontinuity. Points of discontinuity occur when the numerator and the denominator do have a common factor. For example, y equals x plus a over x plus b, divide by x plus a. We can cancel the x plus a so that the equation can be simplified into x plus b. But there is a point of discontinuity. A point of discontinuity which exists at the place where x equals a. So you have to find that out. So you've got to plug in a into the equation, and then you get a plus a, a plus a times, by plugging it in, a plus a times a plus b, divide by a plus a, to see what that point of discontinuity is. We're going to get a lot of practice in this exercise, so turn the page over. So I'm going to approach a number of equations, and we're looking for points at which we're going to have problems. So I want to look to factor, I want to look at the denominator, all of those things in trying to identify first potentials for vertical asymptotes. Vertical asymptotes occur in the denominator. So I'm going to have a problem here when x is equal to minus 4. That's going to cause me problems. There's no problems on x squared plus 4, so no VA here. X squared minus 4 is going to give me a problem when x equals plus or minus 2. That's going to give me a problem. That happens here as well. X equals plus or minus 2 is a problem. It actually can't happen. So maybe it's better to say x can't be equal to, x can't be equal to, x can't be equal to. Here, x cannot be equal to negative 4. Continuing on that adventure, x cannot be equal to plus or minus 2. Here I've got negative x squared. What does that actually mean? It means the negative is outside the bracket, x squared minus 4. Set that equal to 0. Negative x squared equals 4. X squared equals negative 4, which will never happen. Hit record again. It's the same. H ends up being the same denominator. Oh, not quite. In H, I've got that same statement, negative bracket x squared plus 4. When is that going to be equal to 0? That's negative x squared is equal to negative 4. That's x squared equals 4. Here I've got a problem. X cannot equal 2 plus or minus 2. Here I continue with my problem. X cannot equal negative 2. Here I've got a problem in saying that x squared minus 2x equals 0. Factor an x out. That's x times x minus 2, which means x cannot equal 0 and x cannot equal 2. So I found all my vertical asymptotes. Just checking out on letter I. Letter I ends up giving me a discontinuity because I can factor. So I don't have a vertical asymptote. I have a discontinuity because the top can factor into x minus 2 times x plus 2 over x plus 2. So there is no vertical asymptote at I. But I have a discontinuity at I. So B and G, because they have no vertical asymptotes, they will have no discontinuities, no horizontal asymptotes. Think about when that occurs. Horizontal asymptotes occur when the numerator has a higher degree than the denominator. Where does the numerator have a higher degree than the denominator? So the numerator in E has a higher degree, the numerator in J has a higher degree, and the numerator in I has a higher degree. So they have no horizontal asymptotes. As the x values continue to increase, you will continue to get larger and larger values of y, but they will not approach a value. The x-axis has a horizontal asymptote. Remember, the x-axis has a horizontal asymptote means y equals 0. When does that occur? The x-axis becomes my horizontal asymptote when the denominator overpowers the numerator. So that's when the denominator has a higher degree than the numerator. So we want to find those places where the denominator has a higher degree than the numerator. And I found that in 3 places, C, D, and G. Now, when do I get a horizontal asymptote that's equal to y equals 1? Well, they occur when the degree of the numerator and the denominator are the same, and the coefficients of those leading terms are also the same. So we're looking at some of the letters that are left where the degree is identical. 1 and 1, 1 and 1, negative and negative, both squared, 1 and 1. So I have horizontal asymptotes at quite a few letters. I've got them at A, I've got them at B, I have it at F, A, B, F, and H. A, B, F, and H. A, B, F, and H. And then graphs that had points of discontinuity. We need to look at places where there is factoring opportunities. The only other place where I might have done some factoring is in J. In J, I could have taken an x squared out, and then I'm left with x minus 4 over x times x minus 2. because here I have common factors, x times x squared minus 4 over x minus 2. I had the previous statement that x cannot equal 0 and x cannot equal 2, but now I have a point of discontinuity when x equals 0. So point of discontinuity at j and I, which we had already talked about. So I and j have points of discontinuity. And then there was opportunity to factor in earlier ones, just looking for opportunity for common factors. In A, can't factor. In B, I'm not going to get a common factor. In C, I'm not going to get a common factor. In D, I will get a common factor. So when I look at D, I get x plus 2 over x minus 2 times x plus 2. And because I can cancel a factor, and this can be viewed as 1 over x minus 2, this also has a point of discontinuity. So can we put all of our information together and study for asymptotes, domains, and ranges? Here I just have to factor the denominator, numbers that multiply 15 and add for negative 2. That's x minus 5 and x plus 3, which gives me some canceling. So I have 2x minus 1 over x plus 3. And x cannot equal negative 3, and x cannot equal 5. At 5, I have a discontinuity. So at 5, I have a discontinuity at the value x equals minus 3. I have a vertical asymptote. And I also have a horizontal asymptote. Remember, the horizontal asymptote is studied by looking at the degree of the polynomial. And I'm going to get in the numerator, if I were to FOIL that out, that's 2x squared minus 10x minus 1x minus 5 over x squared minus 2x minus 15. I see that my degrees are identical. My horizontal asymptote will come out as being the coefficients of that degree. Y equals 2 is my horizontal asymptote. And then I've got to take a look at the domain and the range. By plugging in 5 into the equation, I can figure out what the y value is, and that's 9 over 8. I identified my vertical asymptotes already. I identified my horizontal asymptote. Now I get to say that x cannot equal 5 or negative 3. X is still an element of the reals. Y cannot equal 9 over 8. And y is still an element of the reals. And I'm able to do this without my calculator's graphing capabilities. Remember, y is also not going to be equal to 2. As x gets very, very large, I will not cross over that number. So thank you very much. That's it for lesson 5. We'll do lesson 6 tomorrow.